Hi, this video is an overview of momentum in physics and how we use it. Momentum is a specialized tool in physics to help us understand some of the more tricky parts of our world and to try to make sense of the way things interact. Especially when it comes to things colliding, we use momentum to talk about how motion can get passed on from one object to another, or to talk about how things can slow down gradually and reduce the amount of force acting on them. To really understand which kind of application we're going to be using when we deal with momentum, we have to ask the question, is there an external force acting on the system that we're analyzing? A system is a collection of two or more objects. In physics, it can even be just one object that you're focusing in on. But when it comes to momentum, we typically have two or more objects that are colliding or interacting in some way. Now, if you are analyzing the objects and you see that there's an external force acting on the system, then that means that the system's momentum will change. A force always causes an acceleration, a change in your motion, as long as that force is unbalanced. And so a net external force acting on our system will change our momentum. And the change in the momentum is equal to the amount of force that's applied multiplied by the time that that force is applied for. This quantity, force times time, is known as impulse. And so this is called the momentum impulse theorem. The change in the momentum of a system is equal to the force times the time. However, if there are no forces acting on our system from outside of the system, then that means that momentum can be passed on between the objects within the system, but the overall momentum of the system does not change. In other words, the momentum is conserved, or it's not lost or gained, it stays the same. And so to summarize the mathematical implications of this type of situation, we can say that the total initial momentum of the system altogether will equal the total final momentum of the system. And so this idea is called the conservation of momentum. This is the idea that I'm talking about in this video when we talk about different types of momentum conservation. There are three kinds of categories of situations that happen. So here are those three categories for momentum conservation. The first one is a type of situation that we nickname explosions, even though most of the time it has nothing to do with something exploding. Anytime you have two objects that are kind of lodged together at the beginning, or they're just at rest together, and then they break apart in some way, they explode, in other words, this type of situation we call explosions. There's another type of situation where it's kind of the opposite of an explosion, where an explosion you start with one object and you end up with two. In this situation, you have two objects, they collide and they stick together. This is called an inelastic collision. In other words, it's a hit and stick collision. Elastic, on the other hand, is when things bounce. If you think of elastic as something stretchy or bouncy, elastic collisions is where two objects collide with each other and they bounce apart. They hit and bounce. And so you can see why we call it inelastic collisions, where they collide and they don't bounce. Elastic collisions is where they collide and they bounce off each other. Typically, we're going to analyze situations in physics problems where we say that collisions are perfectly elastic. There's no deformation of the objects. They don't break or bend at all, and so they don't lose any of that momentum in the collision. We could try to keep it as simple as possible. And so elastic collisions are perfectly elastic. They hit and bounce off each other. So that's all I've got for you in this video. Remember, how you do anything is how you do everything.